Hello. How are you guys doing? That's perfect. That's good to hear. How are you guys enjoying the AppSphere? Is it good? Sweet. Guess you guys have heard there's a bunch of breakout sessions, so we're really excited to have you here. Thank you so much for coming out. It means a lot to us, and kind of sharing this information with you guys, hearing it from you as well, and getting this knowledge flow going. That's really important to us. Thank you. Before we start with our topic today, I'm going to introduce myself. My name is Val C. I'm a senior product manager for AppDynamics. Some of the areas that I focus on are essentially DevOps oriented, so platform features, as well as they touch on upon monitoring and a bunch of essentially the big data stuff as well. From today, we're going to talk about kind of what's new coming out in Java, as well as how do you leverage Java in hybrid cloud, and how does AppDynamics support that move towards hybrid cloud. Actually, can you guys hear me okay? It's all good? Perfect, perfect. All right, so some of the topics that we're going to cover today is going to be mostly about the new Java 8 features, such as memory, which is, as some of you may have heard, the Metaspace move. Then we're going to cover the JVM-based languages, hybrid cloud, as well as microservice refactoring. We're also going to come back to it as essentially always tying back to AppDynamics 2, so kind of see a sense of how that is enabled or helped by us. All right, so before we jump into how many people are familiar with Java 8 and Metaspace? What the hell is a Metaspace? Perfect, perfect. So we'll dive deeper into that. And then, all right, let's see. First of all, this is the breakdown. All right, so the Java 8 memory model from the Java 7, there's been a major switch into how Java does the memory. So essentially, in the old days, and this is kind of a recap, so for Java 7, essentially this was the memory model. You go from the space, goes from Eden to Survivor, back and forth, old gen, perm gen, and the most important thing to realize here, let's see if it works. Not. Oh, there it is. All right. So some things to realize here is that all of this is encapsulated by heap. So all your memory that you can allocate allocate to the JVM. That's all in a heap space right there. That causes a bunch of problems in terms of pre-allocating, because in order to increase that space, you most likely have to restart, bounce the JVM. So that's a problem in case you want to dynamically resize memory. And overall, this is your native memory as well. It's never a good, well, no, in most cases, it's never a good idea to allocate heap to be the same amount of as native memory, because then that can cause all sorts of issues with the app. It may crash and all that. But this is the old Java 7 memory model. The new Java memory model, and this is introduced with Java 8, it's called Metaspace. Now, Metaspace in itself, it's just a fancy word for saying that now your perm gen is gone, and now the perm gen is replaced by this amount of Metaspace memory, which is your native memory. So the memory is no longer encapsulated within the JVM, it kind of lives outside of it. And as you can see right here, the heap itself, you're now bounding the Eden Survivor space in old gen by the new heap size. Your Metaspace memory, so this is dynamically sized in most cases. So if you leave there's a maximum value you can set it as, but if you leave this space untouched, then this is going to grow as your application uses more memory, which is great. You may think there's no longer the out-of-memory issues with permgen, because well, a lot of the times you would get out of memory and then, for lack of a better word, shit hits the fan. This is supposed to solve that. However, it's not as easy as that. So some of the issues that essentially are with the permgen is that the necessary size is hard to predict. With Java 7, it's you either result in under-provisioning, which causes memory overflow, so you get the out-of-memory errors, or over-provisioning, which you're wasting hardware where you can use that for something else. Another issue is the GC performance improvements. As very limited, you can only improve so much of it. And support for advanced optimization, such as G1 concurrent class unloading. We're not going to delve deeper into that, but just that there is a lot of issues here that kind of prohibit you from achieving the most or squeezing more performance out of your JVM. And With the Metaspace now, the memory space, the permgen is completely gone. So you may think that's great, you don't have to monitor it, you don't have to worry about it. But now there's Metaspace, which replaces that. The Metaspace location model is a little different. What you see there is that now most class metadata is allocated out of native memory. And just like we saw there, that memory is not bound by the JVM heap. So if your heap overflows, you're not generally going to cause the out-of-memory errors. And there are no more classes which are used to describe class metadata, which is nice. It reduces your footprint. However, the Metaspace capacity is now limited by the size of the box, which is great because you get dynamic resizing of the memory depending on a demand at runtime. So you no longer have to worry about over-provisioning, under-provisioning. That should always be there. And it's possible to use a flag to bound that. So in case you don't want to overflow a machine, still use that flag. It's called minus. So it's max Metaspace size, essentially limits that size. Now with this, the garbage collection is also a little different. So the garbage collection is triggered once the class essentially metadata reaches a certain size or max Metaspace size. And there is a case that you may get excessive Metaspace garbage collections. And those can lead to memory leaks of classes, memory leaks of class loaders, even improper allocation sizing of all this stuff. So with the Metaspace, there may be some Java heap space impact. It may not be the most significant impact, but you may still get some issues there because now the space is being reused by something that wasn't there before. And with Metaspace monitoring, there are some solutions that are available there. So you can use hotspot GC logs usage, which is not ideal, or AppDynamics. Selfless plug will monitor Metaspace. We'll get delved into how we monitor it and how we show it. So as you can see, the proper monitoring is still required. Is that you may not get out of memory errors as often, but you still need to kind of limit the frequency or delay of these garbage collections. Otherwise, the system will just halt, just do the GC all the time. So use the magic bullet. Not quite. Memory caveats still remain. So it requires, again, proper monitoring because you may still get class memory leaks. You may get class loader memory leaks. So all sorts of leaks may still happen. You need to know where they are or how to track them and monitor. Now, we provide, with AppDynamics, we provide two ways. One is passive Metaspace monitoring, which essentially means that you can go to this page, and that's essentially a hardware view. And you see that in the Metaspace monitoring right here. Let me highlight. So we'll show you this new space. We support it out of the box. You don't have to change anything. You'll see the utilization being used. You see how much of it is being wasted if you need to adjust your max Metaspace size, or if you don't have it, we will not bound this value. And the permgen as well, now this is gone. So as you can see right here, this is really seamless. So as long as you upgrade to Java 8, we support this for you out of the box. The other way is we like to call it the proactive Metaspace monitoring. The proactive monitoring is all about getting the alerts based on it. So in the case of your memory being overused, you can set up an alert to say, send me an email or take some action based on this event. And this really seamlessly fits into kind of how we do alerting. So how many of you guys are familiar with alert and respond features within AppDynamics? Sweet, perfect, that's good. That's good. So that's good to know, because this ties in seamlessly. You define a health rule, nothing new. You just define a health rule, give it a threshold, create a policy, bind it with an action. You're set to go. Nothing new here. So with this, that kind of covers the Java 8, the new features in Java 8 that we essentially kind of some of the things to watch out for, and this is all supported out of the box. All right, so one of the things that I want to mention before we delve into the JVM-based languages is all this functionality is essentially for your Java 8 deployment. You don't really need to do anything. Just upgrade, and you're good to go. All right, so next up is JVM-based languages AppDynamics. And the theme around this is this session is to kind of give you a deal of how the Java has been evolving. And what we've seen from the industry trends is that now the innovation doesn't really happen within Java itself, but most of it is now being taken about how you use Java. Some of them is this notion of JVM-based languages that's been taking off hugely. Some of the languages like Scala, Groovy, all that JVM-based stuff is being used extensively right now, as well as some of the notions that we see nowadays is kind of this microservice refactoring. So Java using that versus innovating on the Java side as well. All right. So with this, the Scala is based on essentially very dynamic, flexible programming language. This is based on the JVM, so it runs on the JVM, compiles to bytecode. The one thing to know is that it's rising in popularity due to primarily some of its flexible aspects. So it's very functional, object-oriented approach is that you can use object-oriented style. If you use functional programming, you have that here as well. It has got some nice constructs to support you with that, as well as Java interoperability, which makes it really attractive if you want to take your prototype from, let's say, the idea phase all the way to production. This kind of gives you all the tools you need and makes it easy for you to develop in it. How many of you guys are core Java guys versus something like JVM-based language? It's core Java mostly. What are you guys' thoughts on essentially the Scala? Or some of the JVM-based languages, you guys are yay or nay on it? All right, yeah, a couple of yays, a couple of nays. All right, so it requires a bit of a shift in how you even essentially program for this, because the language itself is different, everything is different. But that's what we see is that this is being kind of gaining popularity as we go along. Some of the other ones is Groovy. So this is a bit of an oldie. So this is very dynamic JVM-based language, very object-oriented. The best features about it is that it's very simple and it's a very dynamic language. So its simplicity, you can start it. The thing about difference about Java is from Scala, sorry, is that it's a superset of Java, direct superset. So you can do anything. Essentially, you can even type the same expressions in Java and get that in Groovy, but it's easier to adopt. So you can get all these nice constructs. That's what kind of been attractive about it. Some of the other ones we've seen is JRuby. So JRuby is another JVM-based language. So Ruby itself was a very popular language. In addition, if you take down Ruby, if you put it on a JVM, you get a bunch of really nice constructs, such as real threads. You don't have to depend on the virtual threads, which have their ups and downs. You can get real system threads with it, better performance. I want to say that's objectively because Ruby is also improving, so it always goes in and out. But and you get full access to Java toolchains, so all the libraries, everything that you have there is also available through JRuby. All right, so how do you monitor all this? So let's say you've got multi-stack, you've got stacks with Java, with Scala, with .NET. Even so particular this case, as AppDynamics, the real value is in the business transaction. So everything that you see is correlated all the way from the front end to the databases you've seen in other places, and this is no different. So as long as you add a new framework or a new Scala or JRuby, we will automatically correlate that in a business transaction, show you down to the line of code where things are going wrong and all that good stuff. So all of this is kind of remains the same. I get proactive alerts on it, so nothing really changes there. And it's again, distributed cross-stack environment monitoring. So nothing's really new here is that the more of these JVM languages get added, we support them, and you'll get that distributed correlation right out of the box. All right. So there's a bunch more topics. So one of them is hybrid cloud. And some of the stuff you see, we're going to move a little faster just because of the content amount. But the hybrid cloud is, I guess, so before we dive into that, you guys familiar with hybrid cloud? How many have heard of this or even used this in your companies? Very good, sweet. So hybrid cloud is really all about the kind of combining the two aspects of the public cloud and hosting your own private cloud. So in the public cloud, it's really a multi-tenant environment. So you own a slice of a server in a cloud environment shared by other clients. So everything that you access is shared. So any other user can go in and share the same resources, definition of a public cloud. And it's generally used for web servers or dev systems. It may change in the future. For now, that is really where the public cloud shines. Some of the trade-offs is that, again, the hardware sharing. So the bad thing is that meeting compliance requirements is almost impossible in public cloud. So if you do some work that requires you to touch, especially government systems, that's essentially a no-go. Scalability is a good thing. So on-demand resource availability, you don't really have to worry about provisioning any of the resources. The more you need, the more you can use. It's easy. Location independence as well. Wherever you're located, you can place the information in the local zone for your users. So the latency should be low depending on where you put it. So all that good stuff comes with it. Now for the private cloud, it's really all about the single tenancy. So you host your own single tenant environment where only you use those resources that are essentially available. It could be either one single client or single company. So some of the Amazon stuff that they have been doing is building private clouds for bigger corporations, which is still a private cloud, but it's built by Amazon. And it's mostly about expanding on traditional data centers. So you do have to manage a lot of your resources manually. So all of this comes with it. So some of the ones, the resource management is you have to purchase, you have to house, update, and maintain all that hardware and software, as well as update it. So there's a lot of costs associated with it to spin up and use it as you go along. But why would you even use this? Some of the things that pop up is security is a big one. So in the private cloud, you keep the data inside. So it's as secure as it can get versus the public cloud. And the data is scoped to a single entity, so nothing is really leaks or shouldn't leak. And the only entity that has access to is you. So meeting compliance requirements is much easier. So if you do work with government systems, this is a must-go. And you're in direct control of it. So that's kind of the size of this public cloud, very open. You don't have to worry about resources. Just use them and spin them up and down. The concern is security. The private cloud is very nice for keeping your security in one place, keeping your data locked down. But it comes with costs such as resource management. Now, here comes the hybrid cloud. Now, the hybrid cloud is really a combination of both, of public and private. This has seen a huge surge of adoption in recent years, popularized by Amazon and Microsoft Azure. So in a hybrid cloud, you can actually you allow storage and processing of privileged data inside your private cloud, and you can use various computational resources in the public cloud. And how is it done? Well, the unique benefit of this is that you can essentially use let me see, where is this? Unique benefit is that you can take and keep your data all in the private cloud and do the processing there, but gather that data from the public cloud. So you can use this as your web server or as sort of your client-facing, your public user-facing websites, and then transfer the data into the private cloud where you keep it, process it, and store it as well. One of the unique benefits is cloud bursting. We've seen this a lot happening in the recent years, and what that is you use your private cloud for mostly all of your processing and data collection. But the moment you need to go above your resources that you've allocated for the private cloud, you essentially go to public cloud instead. So cloud bursting, in times of need, you go from private to public only when you need it. That's the point of cloud bursting. Now, how's this related to AppDynamics, and how do we essentially, why should you care about this? Well, the monitoring of hybrid cloud, and as some of you have used this before, it's very non-trivial. Knowing exactly where the problem is in the infrastructure side of the private cloud, or infrastructure side of the public cloud, or somewhere in between the network, maybe the connectivity is wrong between these two endpoints. That's definitely non-trivial. It's very complex because of the setup, and it requires a solution that essentially trades distributed transactions all the way through. The root cause identification is very problematic. So all of these kind of downsides come with using all this technology, because keeping the lights on, as IT people know, this is become a nightmare. Unless you have the tools in place, and selfless plug, AppDynamics. So with AppDynamics, you essentially get distributed tracing from private to public clouds. And that all depends with a new feature called cross-app. How many of you guys have heard about the cross-app functionality? Some of you, okay, so let me explain this real quick. For the cross-app, in a normal kind of a general, or more like a simplistic way to define an application within AppDynamics is to define an app. And the application is where all your business transactions, tiers, all your metrics are scoped down to. That becomes your single unit of management, which is your app. Now with a cross-app, you can put those same kind of different infrastructure, you put in a different app, and that way you get nice separation of concerns. You no longer have to tailor the construct of an app, which essentially you would have to modify the tier names to match it. But that's not ideal in some cases. In fact, in most cases, you really want to get the cross-app going, because then you can see that, in this case, for example, this is a correlation between a public cloud and a private cloud. And that way, there's no cross-pollination of metrics. You no longer have to worry about tier names. Everything is scoped nicely. With that, you can essentially define one of your apps that uses the private cloud, put that there. The other app you define to use in the public cloud. You can put that in a separate app. And you get correlation right out of the box. So this is a drill down into one of your apps. And as you can see, this is highly distributed. This, I think this is a private cloud. Yeah, this is a private cloud. Highly distributed private cloud. The moment it makes a call to the public cloud, you see exactly what's going on. So monitoring is literally a breeze. With monitoring hybrid cloud, such a complex environment, it's still very simple with this notion of a cross-app. Now you can separate these two clouds into their separate apps and monitor them to the deepest degree, really. Because once you go, you can see that the same health rules apply. So in case the problem's in the public cloud, you see that out of the box. The same alerts also work there, so nothing really changes. All right. And the next topic is going to be about microservices. And this fits nicely with a hybrid cloud, because most of the deployments, including this one, involves building microservices. Because once you have a monolithic app, splitting it out into splitting out to use the public cloud versus to run on the public cloud versus private cloud is really not straightforward. So in the Java world, this really enables you to build these microservices because of the way the Java is structured in the concept of a JVM. So in microservices, this has been a big shift in modern enterprise. And essentially, it's a move from the monolithic architecture to groups of independently deployable services. And this is my picture of a microservice. I'm not a designer, but that's probably good. So this is the microservice world. This essentially is each of these circles is a service, and it does its own independent thing. Here you've seen huge surge adoptions. This is really that's happening right now in Java as well. So Java popularized this with or is a choice to use this because of the concept of a JVM. So one way to explain microservices is really to start with a monolithic service. So for the monolithic app, and this is the move that's happening, so you go from monolithic to microservice. In the monolithic world, the whole application is built as a single unit. So you get your processing done within one app, you get your UI done within one app. So everything that, and it's in case of, let's say, Java, that's a single JVM or a single WAR file that essentially lives on the container. And for those people, Windows, that's the .executable file on the Windows machine. So that's your single kind of point where all the processing is done, UI is done there. It works for some cases. Most cases that are happening right now, especially with scalability, you really need to go to microservice. And some of the things that characterize monolithic architecture is that it encapsulates, again, all the functionality in a single point, which is a single app. And it's used usually traditional layered approach. And that's something you've seen a lot. So layered approach meaning one of the layers is, in case of, let's say, it's even in the best way probably to describe this would be an operating system. So in monolithic, everything is within one kernel. So one kernel, it has everything in it. So it has the process to go to write a disk, communicate memory together, and take input from the user. Everything is in one place. And this is the monolithic app. So everything lives in one place. Some of the drawbacks is your agility to develop is hindered. The moment you try to go and innovate within the monolithic app, if it was built before your time, you know that it's a nightmare. Technology stack is really hard to change because everything else depends on the technology choices you've made in the past. Even if it's designed properly, there's still, meaning there's abstractions in place to swap things in and out, there's still issues because you gotta integrate different pieces together. It's still really hard. And so changes to the system, in case you wanna make system do something else, it requires probably rethinking and rebuilding of the whole application. With that said, monolithic applications do work for a lot of cases. It's not like this is the bad thing, don't do type of thing. So it does work for some of the cases, but if you want to scale up or scale horizontally, this is probably not the way to do it. Now, what is the way to do if you want to scale horizontally? And that is essentially moving to the microservice architecture. With the microservices, the monolithic piece is now transformed into many smaller services. And typical service is essentially, it encapsulates independent unit of computation. So some of the characteristics that describe this is independently deployable. You can upgrade this independently without affecting the runtime or even the processing of the other services. And it's usually a smaller functionality set. In case of a, let's say, e-commerce app, a microservice would really be all about handling, let's say, user requests from one server, order processing on the other server. So you've seen this happening a lot. And there's a clear module boundary. So one service does not bleed into the other service. Everything is, separation of concerns is very clear. Some of the drawbacks, though, is that remote API calls are very expensive, especially if you make that call through your public cloud and all the way to the private cloud. That latency can kill you. And it requires realigning of different teams. What that means is essentially all that your development will have to really be done so one team will have to be responsible for a single microservice, which we've seen this a lot, that being a drawback to even adopting this architecture. Data consistency potentially can be tricky. And that's, there's all sorts of constructs that exist. For example, the Oracle's caching layer, so the coherence. All of this can be mitigated there. They're not cheap, but they're there. And that means that data can actually be out of date and out of sync with multiple services. So managing that becomes a real problem. Now with that, you really need to know exactly how your microservice is performing, because now if you've built them all, you've connected them together, you want to know how they're doing and what to do in case your microservices or something goes wrong within them. And microservices, again, very highly distributed by nature. So monitoring them is non-trivial if you don't use a solution that uses distributed monitoring. And monitoring health, it becomes crucially important, because once you have so many services, knowing exactly where the point of failure is highly important. And some of the things that you can identify with this is API calls can be streamlined effectively. And I'll do a demo of this as well. So, and what that means is once you have the microservice making a call to the other microservice, you need to know down to the line of code where exactly you need to optimize your performance. And again, the more moving parts you have, the more complex it becomes. It's kind of a given. And it's hard to nail down the root of the problem. So with all this combined, the monitoring of microservices with AppDynamics becomes really simple, because nothing really changes in terms of your app flow. Each microservice within your app can actually be a tier. It makes sense, because now that you've moved from a single monolithic app, you move to a distributed microservice app. So all of these tiers can now be your microservices. And it's all up to you how you want to split them up, or it's usually best to do one tier per microservice. And that way you can know exactly where the point of failure is, where it's in the communication channel, or if it's on the database call of particular microservice. All of that is there. And one of the things that we've seen as well is this new popularity of Docker containers. Assuming most of you guys are familiar with Docker. How many people have heard of Docker, used Docker? Pretty much everyone. So Docker's been immensely successful. And that essentially, a Docker container can be considered a microservice. In the way that you build it, you deploy it, you link them together, and then they talk to each other. That is essentially the microservice architecture. The one way to, so a little secret behind everything you see on the screen, all of this is running in Docker right now. So everything you see on the screen is in fact a Docker container. So each of these little guys right here, we pop up the metrics. So each of the tiers is actually running in Docker. So the more containers you spin up, the more nodes are going to show up. You're going to see the load being distributed properly. If you spin them down, in time they'll go away from your flow map. With this, you can actually trace down whether you need to scale up or scale down. So all of this functionality is embedded within AppDynamics. There's no real difference into showing that this is a Docker container. And essentially, as you drill down into each of these, let me show you here. Choose the one that has multiple clusters. All right, so this one right here. So this is a cluster of nodes, and each of these nodes is a Docker container. And the way they communicate is by talking to each other. So these are all the Docker containers, Docker services talking to each other through your simple API calls. And for most of you, you've seen this a lot in the past. The troubleshooting is really easy. If you want to see exactly where the point of failures are for your particular Docker containers, you see them all right here. And especially this is for you guys that have seen, you will resurface any potential issues that are happening within your microservices on the same screen. So anything you see right here, for example, there's this slow method that we've identified, there's an error, which is pretty important in creating an order. But with this, you're not really worrying about how to connect the microservices together. We'll map you the map of your microservices. So everything you see on the screen is automatically detected the way you configure it. And if each microservice makes a call to some shared server, for example, to some shared database, and if there's latency in that, then your microservice app will quickly become slow, because there is memory contention, all the sort of kind of problems that are happening within the monolithic app can also happen here if you have shared resources. And we'll show you that right here. We'll show you where the states of each microservice is, what they're doing. as well as once you drill down into the database, and this can also be your other microservice, which is a database. And this is, again, a database that runs within a Docker container. You'll see exactly where the time is being spent. So nothing is, no visibility is lost if you move from monolithic app to a microservice app, all the way down to the query level. All right. So let me see right here. All right, and similar concepts apply to the cross app as well. So in case you have, and this is, again, this is, in this particular example, what I'm showing here is a private cloud talking to a public cloud. In combining these two things together is really non-trivial in a traditional monitoring sense. With our AppDynamics, you can do that right out of the box. We'll detect that it's a cross app. We'll show you the clear separation of concerns. We'll also map up your microservices as well as the shared data that they're referencing and how they're communicating together, where you can optimize your application, whether it's in the latency or the time is spent is, let's say, from the order service communicating to the fulfillment service. You see all that right here. One thing to note, but one additional thing is about microservices, that most of the microservices themselves, they communicate, or they should, in theory, only use their own data store. So in this case, these two databases should never be used by any other microservice. That's a general good rule of thumb. And with that, that would be all from me. And the one thing that I did want to mention is that, to conclude, most of the Java stuff that we're seeing is Java remains a major player in the enterprise development. There's no doubt about that. But the new trends that we're seeing, they're no longer centered around the Java's core features. They're mostly all about centered around the whole cloud hybridization model, microservice architecture, as well as all these JVM-based languages that we see just becoming more popular every day. Some of the recaps, so Java 8 has introduced the new feature called Metaspace, replaced PermGen. You don't lose visibility with AppDynamics. You still get visibility into the Metaspace, still optimize it. There's still issues, but we'll help you monitor it right out of the box. You can do passive alerting. You can do active alerting, proactive monitoring as well. And with the microservice, again, nothing really changes from the AppDynamics perspective. We'll show you everything. So if you move your app, all of a sudden you move it from the EC2 instance to a Docker container, the whole visibility, everything remains the same. And in terms of the hybrid cloud, again, so hybrid cloud is really the popular move that we'll surely see grow more and more with every day. Monitoring hybrid cloud is non-standard, and you can totally do that with AppDynamics by essentially separating them into different apps. So the moment you separate one cloud to a different app, the other cloud to the other app, you will not lose correlation. You'll still see exactly how your clouds are connecting, and you can use both public clouds benefits and private clouds benefits as well, so for your enterprise. Depends on how you want to choose. And with that, I want to thank you guys as well for listening, and some of the things, and again, this really means a lot to us that you're coming out. So AppSphere is a big event for us, and we want to thank you for being here with us, for sure. Thank you.